In this third section of 7.3, we are going to be looking at another method for solving systems algebraically, which is a method called substitution. So as you guys know, to substitute means to replace something for something that is just like it or something that is equal to it. So when we are doing the substitution method, we will be looking at equations, first of all, that already have one of the two equations solved for x or solved for y. So if you look at this first example here, question number 1, on question number 1, if you notice in the second equation, y is already by itself. So in this bottom equation here, y is already alone. So it says y is equal to something. So if y is equal to negative 4x plus 24, then that means that y is the same as negative 4x plus 24. So we can take this expression here that y is equal to, and we can substitute it in place of y in the other equation. Because if they're equal, then one can substitute for the other. So that means our top equation is going to become 2x minus 3. So it was 3y. So that would mean 3 times y. Since we're replacing y with this whole expression, we're going to have to use a set of parentheses. And that's equal to negative 2. So now we have created an equation that we will be able to solve for x. So to start solving this, we're going to need to distribute 3 to here and to here. So when we do that, we find out that 2x plus 12x minus 72 is equal to negative 2. So now on the left-hand side, I have like terms. So 2x and 12x are like terms, so I can combine those, which gives me 14x minus 72 equals negative 2. Now I just need to solve for x, so get x by itself. So I'm going to add 72 to both sides of the equation, so these will cancel, meaning that I can say that 14x is equal to 70. And then I'm going to divide both sides by 14. So these 14s cancel, and I find out that x is equal to 5. Now, just like what you did with elimination, we are going to take that value, that 5, and substitute it back into one of the two original equations to solve for the other variable, so to solve for y. So I'm going to choose to substitute it into the second equation because y is already by itself there, so it will be easier for me to solve. So I know that x is 5, so I can say that y is equal to negative 4 times 5 plus 24. Negative 4 times 5 would be negative 20, so negative 20 plus 24, which would give me a positive 4. So because this is a system, our answer is still the point of intersection, the x comma y, so our answer would be 5, 4. Moving on to question number 2 here. In question number 2, you're going to see that, again, we have a situation, this time in our top equation, where one of our variables, y again, is already by itself. So I can take this expression, negative 2x plus 9, that we're saying y is equal to, and substitute it into this second equation. Now you need to be careful with that negative that's out in front here. That would technically be a negative 1. So I will have negative 1 times negative 2x plus 9 plus 3x equals 16. So I need to distribute this -1 to here and to here. So when I do that, I find out that 2x minus 9 plus 3x equals 16. I have like terms on the left-hand side. 2x and 3x are like terms. So I can add those together and get 5x minus 9 equals 16. And now I need to solve for x. So I'm going to add 9 on both sides of the equation. These will cancel. So I can say that 5x is equal to 25. And then when I divide by 5 on both sides, these 5's cancel out, and I find out that x is equal to 5. So now, just like in the last one, I'm going to take that value and substitute it back into one of the two original equations. So if I choose the top one, which was y equals -2x plus 9, I now know that x is equal to 5. So y equals -2 times 5 plus 9. -2 times 5 is -10. So I have -10 plus 9, which is -1. So my point of intersection, or my ordered pair here, is 5, -1. So two more examples to look at here. Very similar, but now you're going to notice that in example 3, neither of the two equations have one of the variables by themselves. But in example 3, the second equation is close to having y by itself. So if I wanted to get y by itself here, I could do that by dividing by 5 on each term. So when I do that, these cancel, and I find out that y is equal to 1x minus 1. So now that I know that y is equal to 1x minus 1, or y is the same as 1x minus 1, I can take this expression and substitute it into the opposite equation in place of y. So that means I will have -4x plus 2 times 1x minus 1 is equal to -6. So to solve this, I'm going to need to first distribute. So -4x plus 2x minus 2 equals -6. On the left-hand side, I have like terms, so -4x and positive 2x are like terms. So when I combine those together, I get -2x minus 2 equals -6. So to finish solving for x, I can add 2 on both sides. These cancel. So -2x is equal to -4. And then divide by -2 on both sides. We know that a negative divided by a negative becomes a positive. So x is equal to +2. So now to find y, I'm going to go back up and substitute into one of the two original equations. Always go all the way back up. So I'm going to use that bottom one, which was 5y equals 5x minus 5. So I'm going to substitute in 2 for x. So 5y equals 5 times 2 minus 5. 5 times 2 is 10, so 5y equals 10 minus 5. 10 minus 5 is 5, so 5y equals 5. And then to finish solving here, I'm going to divide both sides by 5. So I find out that y equals 1. So my point of intersection is 2, 1. So one final example here, question number 4. In number 4, neither of your equations are solved for x or solved for y. So it's completely up to you which one you want to solve and whether you want to solve it for x or y. I'm going to decide to use the second equation and I'm going to solve it for x. So negative x plus 2y equals 6. So if I wanted to get x by itself here, I would start by subtracting 2y from both sides. So these are gone, meaning I can say that negative x equals 6 minus 2y. And then I need to divide every term by negative 1 so that I can find out what x is equal to. So these negatives cancel. And I can say that x is equal to negative 6 plus 2y. So since x is equal to that, I can take this expression here and substitute it into the opposite equation in place of x. So that means I will have 2y minus 2 times negative 6 plus 2y equals 8. So I need to distribute here, and keep in mind that what I'm distributing is a negative 2. So I have 2y plus 12 minus 4y equals 8. I have like terms on the left-hand side. 2y and negative 4y are like terms. So negative 2y plus 12 equals 8. So now to solve for y, I need to subtract 12 from both sides, telling me that negative 2y is equal to negative 4. And then I'm going to divide both sides by negative 2. So when I do that, I find out that y is equal to positive 2. So now I'm going to go back to one of the two original equations. So if I choose the second one, it was negative x plus 2y equals 6. And I now know that y is 2. So negative x plus 2 times 2 equals 6. 2 times 2 is 4, so negative x plus 4 equals 6. I'm going to subtract 4 from both sides, which means that negative x equals 2. And then I'm going to finish by dividing by negative 1 on both sides. So these cancel. And I can say that x is equal to negative 2. So my point of intersection here, my ordered pair, would be x and then y. So negative 2, 2.